All right, this is still 10.1. This is part 2. We're going to pick up with type 1 and type 2 errors. And remember that there are 4 different things that can happen when you perform this test. You can reject the null hypothesis when it is true. You can reject the null hypothesis when it is not true. You can fail to reject the null hypothesis when it is true, and you can fail to reject the null hypothesis when it is not true. Only 2 of those are correct decisions, and the others are not. And remember, we're dealing with probability. We're not always going to be 100% correct. But the type of error, type 1 and type 2 errors, occur when you make one of those mistakes. So a type 1 error occurs when you reject H naught when it is actually true. And alpha is the probability of making a type 1 error. And remember, alpha is part of what's given in the problem. That is one of the things we have to know in order to perform the test, because we want to minimize the type 1 error probability. The type 2 error is when we fail to reject H naught when it's actually true. So if we reject H naught, but it was actually true, in other words, we reject the status quo, but the status quo was actually true, we've made a type 1 error. And if we fail to reject H naught, which is the one that has the equal in it, if we fail to reject it, but it really is not true, then we have made a type 2 error. And the symbol for the probability for that is beta, and we don't really deal with beta. It's just that it's related to alpha. As the probability here goes up, the probability here goes down, and vice versa. So if we look at an example, if the null hypothesis is that the defendant is innocent, and typically in a trial we say that someone is innocent until proven guilty, so the proof has to be for the alternative hypothesis. That's what we're looking for evidence of. The assumption is that they are innocent until we find evidence to the contrary. So we're looking at which one of these would be a type 1 and a type 2 error. If we reject H naught, in other words, we find that the defendant is guilty when in fact they are innocent, that is a type 1 error. And that would be finding an innocent person guilty. That would be a type 1 error. Obviously, in the court system, we try to minimize that probability of that happening. A type 2 error, we do not reject H naught when H1 is true. That is a type 2 error. And that would be finding a guilty person not guilty. Now, when we do a trial, we typically don't have a verdict of innocent. There are some circumstances where that comes up. But typically when you have a jury, they find the defendant guilty or not guilty. If the person is really guilty, they did, rob that bank, but there's not enough evidence, they didn't prove their case, then if the jury says they're not guilty, that would be a type 2 error. The type 1 error would be that the person didn't rob the bank, but there was some evidence indicating that they did, maybe someone who looked like them, or maybe their car was in the area, who knows, and then they're found guilty. That would be a type 1 error. All right, determine which of these would be a type 1 error and what would be a type 2 error in these tests. A reporter claims that more than 50% of workers find their jobs through networking. So this is a proportion because it gives us a percent. So the null hypothesis would be that P equals 0.5. And this says that more than 50%, this is the claim. So the claim, the alternative hypothesis is P is greater than 0.5. And we've got greater than is up here in this right tail. And a type 1 is reject H naught when H naught is true. So we would reject P equals 0.5 when P equals 0.5 is true. So we would be saying, now remember the alternative hypothesis is that it's greater. We can't reject P equals 0.5 in favor of something else because all we tested was this. We can't say it's really less or it's really something else because this is all we tested. So if we reject this one, then our evidence must have supported this one. And if this one is really true, but we're saying we're going to accept this, then we have made a type 1 error. A type 2 error is when we do not reject P equals 0.5, but P equals 0.5 is not true. It's not really 50%, but the evidence wasn't strong enough for us to reject that, so we have failed to reject P equals 0.5, but in reality, it's not 0.5. That would be a type 2 error as opposed to a type 1 error. In this one, we have a sociologist who claims that the average age when teenagers begin working is less than 15. So remember, the null hypothesis always has an equal. Average means a mean, so the mean is 15. If you take the mean of all teenagers and how old they are when they start to work. And this person says they think that the mean is less. So the mean is less than 15. And again, we can draw a little diagram. And less than is a left-tailed, so that means we're looking at this probability down here. And if we reject H naught when H naught is true, that means we reject mu equals 15 when mu equals 15 is actually true. It really is 15. That would be a type 1 error. And a type 2 error would be we do not reject mu equals 15 when mu is less than 15 is true. So we didn't have enough evidence to reject the null hypothesis, but in reality, the claim is that it's really, the average age is really less than 15. This was really true, but the evidence wasn't strong enough to reject this. That is a type 2 error. So those are the two types of errors that we can make. So the steps in hypothesis testing. First of all, a lot of this is going to come from the problem and a lot of it's going to come from the calculator. So there's not a lot to do other than to read carefully and make sure that we know where all this information is and write it down. Extract important information from the problem, write down and label the values such as x, n, p hat, x bar, s, all of those symbols. State the claim with the symbols. These are the parameters we're going to be testing in this chapter. So our parameter will involve one of these. These are the test statistics. We don't involve those in the hypothesis. The hypothesis is a hypothesis about a parameter. So we state HO and H1 with symbols, one of these, and we label the claim. The claim is always going to be H1. That is the claim. So H naught should include the equal statement and H1 should include either less than, greater than, or not equal, and that is going to be the claim. We determine the alpha level. That typically will come from the calculator, and determine the critical value of Z, that or T. We don't use T at all. The critical values for Z are given in these notes, which I will post after they're finished. And remember, we had a little table that had those in it back here. If you need to look at that, we're not going to test it that way, so that won't be as important for us. And so this comes from the problem, and this you may or may not have to do. It's not how we're going to work the problem. Calculate and state the appropriate test statistic. This will come from the calculator, and whether it's a Z or a T, and it will tell you when you pull up the test, Z equals or T equals, and you'll even know which one it's supposed to be because first of all, you had to choose the right test, and then once you choose the right test, it will tell you if it's a Z or a T. Draw the appropriate graph showing the critical region or regions. Again, the calculator will do this for you when you choose the draw option, which we'll look at in 10.2. We'll start actually performing this on the calculator. Calculate and state the p-value. The calculator will give you that. The calculator will draw this for you when you choose draw instead of calculate when you do the test. State the appropriate decision. We either reject H0 or do not. These are our only choices. Reject or do not reject. We don't say prove. We don't say I think this is true. We just reject or we do not reject. We're going to be doing the p-value method, not the classical method. So if the p-value is less than alpha, remember alpha will be stated in the problem and the p-value comes from the calculator. If the p-value is less than alpha, we reject H0. And so this is a little mnemonic to help you remember. If P is low, ho must go. So we reject H0 if the P is lower than alpha. If the p-value is greater than alpha, we do not reject H0. And then we write the final conclusion or decision. If we reject, if the test tells us to reject H0, then we write there is sufficient evidence to conclude that, and then we just restate the claim. Don't get creative, just restate what the claim said. And do not reject H0. There is not sufficient evidence to conclude that, and then you restate the claim. So these two are very simple. Just one of them has a not in it and one of them doesn't have a not in it. And other than that, they should be, just use this as a template. You don't have to get creative on your own at all. And that's how we will perform those tests. In the next video, we'll start with 10.2 and start looking at actual hypothesis testing.